we're going to look at today, we're going to do a few experiments on varying resistance, or what factors affect resistance of something. So remember we said that resistance is the resistance to charge, so it's sort of like it can limit the amount of charge flowing in a circuit. So the higher the resistance, the lower the current in the circuit. I always think of it as like a wall. So if you build a higher wall, it's more difficult for it to climb over, so it sort of slows the current down a little bit. That's kind of the way I think of it. So the higher the resistance, the lower the current. Okay, so that's important when we're doing these experiments. Now, normally, I would get you all to do like a circus of activities, but we can't do that at the moment. So what I'm going to do is I'm going to show you pictures of each experiment, and then you're going to do the experiment that's on your desk. Then you're going to explain to the rest of the class what's happening. Okay? Yes? Yes, I know. So maybe I'll get somebody. Does anyone want to volunteer to come and do this on their own? No, or I can always tell you what the answer to that one is. That one's the most fun one, by the way. This one over here. I can always tell you the answer. Right, so the front desk, the first experiment, which is experiment 1 in your booklet, is short and long wire. So it's the same thickness, there's just short and long wire. So what you're going to do is you're going to connect your long wire into the circuit, see what the current is, then take your plugs out and stick them into the short wire and see what the current is, and write that down in your table, and then come to a conclusion. Is the longer the wire higher or lower resistance? So that's your first one. So this is page 4. So that's experiment 1. Oh, hello. So we do have someone at the front desk now. You're not on Heats? Okay. Right, the second one, which is Stuart and Courtney's desk, is we've got 3 thicknesses of wire. Now they're all on the same board, but all you need to do, this one, the top one is the thin one. So when you're using the thin one, you plug it into this side and this side and measure the current. Then unplug them both, plug it into here and here. That's your medium thickness. And then unplug them both and plug it into here and here. And the bottom one is your thickest wire. So that's that one. Then the back desk, you have got a light dependent resistor. So that's experiment 3. Hello. So experiment 3, this thing here is a light dependent resistor. So you just need to connect it up, okay, completely. And then it says LDR in light and LDR in dark. So to darken it, you just put your hand over it and measure the current. In light, just take your hand away. Okay. Then the next one, experiment 4, is a thermistor. So that's what you've got, Craig, Jamie, and Cameron. So for this one, you need to plug it in fully. Jamie, thank you. And it says thermistor in cold and hot. So basically, cold is just room temperature. Hot, you can just heat it up with your sort of hand. You can put your thumb over it and just heat it up, or do that with your hand and then put it over it. Okay. Then we have got this one here, which Charlie's got all to himself at the moment. It's a variable resistor. So all you need to do is just connect up the circuit. So, and then you're sliding your variable resistance from one side to the other side. Okay, and filling in the gaps. And Harris, you've got the fun experiment at the end. So what you're doing is you have got a circuit there. So all you need to do is plug in this wire into here. Then you've got 2 separate metal rods. So you hold them loosely at first, measure the current. Don't worry, it's completely safe. Hold them tightly, measure the current. Then what you're going to do is just dampen your hands a little bit and do the same, so loose and tight. It's completely safe. You're not going to get an electric shock or anything. And fill in the gaps. Have you got your notes? We're on pages 4 to 6, so you're the last experiment there. So at each desk, you're going to do an experiment, and then I'll get you to feed back to the class once you're done. So I'll give you 5 minutes to do it. It shouldn't take that long. And then make sure you fill in the gaps as well in your conclusions. Any questions? Right, off you go. So we'll start off, we'll just go through it in order. So resistance and length. So what did you get for your results, girls at the front? 0.17. Oh, I've got the rainbow pen on. 0.22 and 0.17. Okay. And your conclusion, the longer the wire, the bigger or the higher the resistance. Good. Okay. Resistance and thickness. So second desk back. What did you get for your results for thin, medium, and thick? 4.09. Sorry? 4.09. 4.09. Yep. 4.18. Yep. And 0.38. Okay, good. So what did you get for your conclusion? The thicker the wire, the... Yeah, higher the current, but lower the resistance, yeah. It does mess with your brain a little bit because you're like, oh, it's a higher current, but it's actually a lower resistance. Yeah, very good. Okay, the light-dependent resistor. What did you get for your results? Anyone at the back? 0.2. Okay. So what did you get? The brighter the light, the resistance of the LDR. Yeah. So it's much higher in light. The current is much higher in light, so the resistance is much lower. Now, to remember that, this is a light-dependent resistor, so it's very specific to the actual component, which is a light-dependent resistor. To remember it, light up, resistance down. You'll come across these again when you do electricity 3, but light-dependent resistors, when light goes up, the resistance goes down. Okay? Right, thermistor, what did we get for our results for thermistor? 0.36 and 0.46. So higher when it's hot. So the higher the temperature, the resistance? Because the current is higher. And to remember this one, and this is, you very rarely get to hear this word in physics, TERD. Temperature up, resistance down. Okay, so TERD and LERD, and they are specific to those components. Other resistors do the opposite, but a temperature-dependent resistor, when the temperature goes up, the resistance goes down. In normal resistors, we might just write that actually, normal resistors do the opposite. So in just normal resistance, as the temperature goes up, the resistance goes up. But in temperature-dependent resistors, TERD happens. Okay. Right, experiment 5, the variable resistor. So Charlie, you have probably had the most writing to do of everybody. So you're moving the variable resistor to one side and then to the other. So the variable resistor at the maximum resistance, what did you get for that? Is that amps? Yeah. Yep. And what did you get for the minimum resistance? So higher current at smaller resistance. When it says lamp it basically means was it a dim or bright? So the top one would have been a slightly dimmer, hopefully, and the bottom one would have been brighter. So what did you get for your conclusion? Yeah. Good. Everyone got that? Okay, and Harris, your one, your skin resistance one, what did you get for your, do you want to just go through the currents one by one for me? Both off the scale, yeah. So the current, that means off scale means the current was too high to read on the scale. So first of all, if you look at the top two, the tighter the grip, the resistance? Yep. And the wetter the hands, yeah. Good work, everybody. As I said, usually you get to all play with these, but unfortunately we can't at the moment. Right,